Here's section 6.4, day 2, part 2. This is the last video for day 2. At the end of this, your note should be complete.
Alright, so now we're going to do a word problem based on our product properties of square roots and or our quotient property of square roots. How do we take those properties and actually use them within word problems? So I gave you a finding the volume. But again, remember how when we started learning volume, you had integers, like this box was 5 by 2 by 3. And we learned the formula and we used integers. And then your teacher spiced it up by using decimals or fractions. Well, again, we're layering this other piece on top of you. Now you know the existence of square roots. So if you look at your image, no longer are the dimensions as integers or decimals or fractions. Our dimensions are by radicals. And we need to know how to use our properties to be able to simplify that. So find the volume of this rectangular prism. So I have to think about my plan is. And most often with geometry, your plan will be your geometric formula. And hopefully you remember the formula for volume of a rectangular prism. If not, in your planner, you'll find the math page. I believe it's on page 8 or 9. And your formulas are there too that you can use. So our plan is to use the volume formula, which if you remember correctly, it's length times width times height in a rectangular prism. I'm going to give myself the key so that I can see what's going on. The length is something, my width is something, my height is going to have a value, and my v is going to have a value. If there's 4 variables in my formula, there should be 4 variables in my key that I'm going to use to substitute later. So looking at the picture, the length is the radical 5. My width, how wide is this? The radical of 10. And then my height, how tall is this? It's the radical of 2. And the volume is what I'm solving for, so that's my unknown. Okay? So we have length by width by height, and when we compute, we leave out the units until our last conclusion in sentence form. So now I'm just going to substitute in. So volume is equal to my length, which is the radical of 5, times width, which is the radical of 10, times height, which is the radical of 2. So I have this radical multiplication, but I think it looks like it's the product properties backwards. So remember in the product properties we had a single number? I believe that the video was based on the radical of 50. We broke that into its factors. And we said the radical of 50 was the radical of 25 times 2. And then we broke that up into the radical of 25 times the radical of 2. Well, in this problem, we're starting at the product property here. And we're moving this way towards the negative 50 because we're starting with the factors of this radical. We're not starting with the product. So I'm going to do exactly what I did in part B, but backwards. So I have this, so I regrouped both factors under one radical. So that's what I'm going to do here. I'm going to have my volume equals, I'm going to give myself a long radical bar, and I'm going to take the 25 and the 2, put it under. In this case, I'm going to take the 5, the 10, and the 2, and put it under. So I can take the square root of each factor, or I can find their product and take the square root of it. So I rewrote it, so I'm right here on this step, rewrite the factors under one radical bar, now multiply that to get the product of those factors. So the volume is equal to the radical of 5 times 10, which is 50, times 2, which is 100. Too long with the radical bar. So the volume is equal to the radical of 5 times 10 times 2, and now I find their product. The volume equals the radical of 100, which hopefully you're saying, oh, nice, because that radical of 100 is a perfect square now. So now when I take the square of both, when I take the square root of both sides, we can say that the volume is equal to 10. The square root of 100 is 10. So now looking back at my conclusion, what is the volume of this rectangular prism? The volume is 10. And then when we look, we have meters times meters times meters, so it's meters cubed.
Any students in grade 6 to 8
On that bag. I thought they were going to say Jamie. And it was from the office.
Here is your checkpoint for day 2. At the bottom you'll see the 3. This is the end of your notes. You should be done, and we'll talk about it tomorrow.